What if I told you that a model with 3 billion parameters, small enough to run on your laptop, could outperform a 100 billion parameter cloud model on your specific business task, offline, privately, and at a fraction of the cost? That is not science fiction. That is the reality of small language models. Welcome to the practical alternative to LLMs. On the left, a cloud-hosted giant, over 100 billion parameters. You pay per token. Your data leaves your network and goes to a third-party server you do not control. On the right, a 3 billion parameter model running on a laptop. Private. Offline. Essentially free to run after the initial setup. The question is not which model is bigger. The question is which model is right for your specific task. Think of it this way: a cloud LLM is like renting a massive factory every time you need to build something. A local SLM is like owning a specialized workshop in your garage. The factory can do more things, but the workshop handles your specific needs better, faster, and cheaper. Small language models are not a different kind of AI. They use the exact same transformer architecture that powers GPT, Claude, and every major language model. Before transformers, AI systems called RNNs process text word by word, like reading a book one letter at a time, slow and hard to parallelize. Then came the 2017 paper, Attention is All You Need, which introduced the transformer. Transformers use a mechanism called self-attention. Instead of reading word by word, the model looks at every word in a sentence and asks, which other words matter most for understanding this one? It is like reading a whole paragraph at once and immediately seeing how all the ideas connect. This is the foundation that powers both the largest cloud LLMs and the smallest local SLMs. So what counts as small? A parameter is like a tiny dial inside the model, one of millions or billions that gets adjusted during training. There is no official cutoff, but in practice, SLMs stay under 10 billion parameters. At the bottom of the ladder, 500 million to 3 billion, these run on phones and edge devices. 3 to 7 billion is the sweet spot for practical local deployment, small enough to run on a consumer GPU, big enough to be genuinely useful. 7 to 10 billion is the upper SLM range, still deployable on a good workstation. Above 30 billion, we are firmly in LLM territory. These need data center hardware. And above 100 billion, you are looking at the largest commercial models. Popular SLM families include Phi from Microsoft, Gemma from Google, Llama from Meta, QN from Alibaba, and Mistral. Each offers different sizes for different needs. Here is the key insight. A generalist cloud LLM is like a Swiss Army knife. It can do many things, but none of them with surgical precision. A domain-specific SLM is like a surgical scalpel. It does one thing, and it does it extremely well. The cloud LLM has broad knowledge across thousands of topics, but it does not know your specific business, your internal processes, or your proprietary data. The domain SLM is trained on your data, understands your domain deeply, runs on your infrastructure, and keeps your data private. The question is not which tool is better in absolute terms. The question is which tool is right for your specific task. For broad creative brainstorming, reach for the Swiss Army knife. For a specialized business workflow, reach for the scalpel. Closed-source generalist LLMs are powerful, but they come with 6 real risks that matter for business. First, data leakage. Your prompts may contain sensitive company information that leaves your network and may be retained by the provider. This is a major concern for healthcare, finance, legal, and manufacturing. Second, model drift. Providers can update their models without notice, and a workflow that works today may behave differently tomorrow. Third, unpredictable costs. Token-based pricing grows quickly at production scale. Fourth, lack of transparency. You cannot audit the training data, check for biases, or verify copyright compliance. Fifth, hallucinations. The model can invent facts that sound convincing but are completely wrong. And sixth, compliance problems. General-purpose models are not automatically aligned with sector-specific regulations. If you work in a regulated industry, these are not theoretical risks. They are deal breakers. Here is the better path. Instead of building a model from scratch, which costs millions, you start with an open-source pre-trained SLM. Then you feed it your domain-specific data, clinical notes for healthcare, legal contracts for law firms, maintenance reports for manufacturing. You apply PEFT or parameter-efficient fine-tuning, which updates less than 1% of the model's parameters. The result is a specialized SLM, a model that is now an expert in your domain. and you can deploy it anywhere, on a laptop, an on-premises server, or an edge device. Think of it like this. A generalist LLM is a Swiss Army knife. It can do many things adequately. A domain-specific SLM is a surgical scalpel. It does one thing with precision. Among the customization strategies, full fine-tuning is the most powerful but the most expensive. Partial fine-tuning is cheaper but requires experimentation. PEFT, especially low RA, is the practical default, low cost, strong results, and you can swap adapters for different tasks. So when should you use which approach? Use a generalist cloud LLM when your task is broad and general, privacy is not a concern, compliance is not a constraint, and you need quick prototyping or creative assistance. But use a domain-specific SLM when data privacy is critical. The model must run on-premises or offline. The task requires specialized domain knowledge, regulatory compliance matters, cost predictability matters, or you need reproducible and controlled behavior. If privacy, compliance, or reproducibility is a hard requirement, and for many businesses it is, a closed-source generalist LLM is probably not the right foundation. The right model for the job is not always the biggest one. Getting started is practical and the barrier to entry has never been lower. Step 1. Define your task precisely. Do not just say we need AI. Say we need to classify support tickets, or we need to summarize clinical notes, or we need to extract clauses from contracts. Step 2. Audit your data. What do you already have? Is it labeled? Is it clean? Step 3. Choose a base model with the right size, license, and community support. Step 4. Start with PEFT or low RA as your tuning strategy. Step 5. Evaluate on task-specific metrics, not just generic benchmarks. Step 6. Deploy using tools like Llama for local experimentation, Llama.cpp for CPU and edge deployment, VLLM for scalable serving, or TGI for production. The ecosystem is ready. You just need to start. 5 key takeaways. First, SLMs and LLMs share the same transformer foundation. The difference is scale, not architecture. Second, a smaller model trained on focused data can outperform a larger general model on narrow specialized tasks. Think specialist versus generalist. Third, closed-source generalist LLMs create real risks around data privacy, unpredictable costs, model drift, and regulatory compliance. Fourth, transfer learning and PEFT make domain specialization practical and affordable. You do not need a supercomputer to customize AI. And fifth, PEFT methods like low RA, training less than 1% of parameters, are the best starting point for most business use cases. The future of practical AI is not about the biggest model. It is about the right model, trained on the right data, deployed the right way. Smaller, private, specialized, and fully under your control.